Okay, today we're going to do 5.2, systems of linear equations in 3 variables. So an equation such as x plus 2y minus 3z equals 9 is called a linear equation in 3 variables, okay? General, an equation of the form ax plus by plus cz equals d. For a, b, c, and d are real numbers, that's important, right? Always real numbers, not imaginary, such that a, b, and c are not all 0, is a linear equation in 3 variables. Those variables are x, y, and z. The graph of this linear equation in 3 variables is a plane in 3-dimensional space. So we're no longer in 2-dimensional space. We're now stepped into the realm of 3-dimensional, okay? A solution of a system of linear equations in 3 variables, so the solution variables is an ordered triple of real numbers that satisfies the equation of the system. So this is how it looks to graph 3D. It's pretty cool. Usually we have our y axis, right? So we have y and x, right? That's how it usually looks. And here's our x. Well, now we have a z that comes straight up at us, and this is our z. So it just kind of rotates everything, and we have a z that comes up. That will not be on the test. I just think it's really super cool, so you guys will get to see it because I think it's cool. That's kind of the way this class works, right? I think it's cool. Y'all get to look at it. So here's our y. Now here's our x, and then the z is what comes like directly at us. Okay. So the first thing we're going to do is we're going to show that the ordered triple, -1 to -2, is a solution to this system. Okay. So -1 is our x, 2 is our y, and -2 is our z. So this is our ordered triple. Okay. So what we're going to do is we're going to take each of these and plug it in to each one of these equations. So let's start with the first one, which is x plus 2y minus 3z equals 9. So we're going to plug this in. It's going to be -1 plus 2 times 2 minus 3 times -2. Side should end up equaling 9. So we have -1 plus 4. Negative times a negative gives us a positive, right? So 6 plus 4 is 10 minus 1, 9 equals 9. So that's a true statement. Now let's move to the second one. So this is going to be our 2x minus y plus 2z equals -8. And once again, we'll plug these in. So 2 times a -1 minus 2 plus 2 times a -2. This should equal a -8. Well, this is going to give us a -2 minus 2 minus 4. So -4 plus a -2 is -6 plus another, easy for me to say, another -2 gives us a -8. So that's a true statement. Man, that was tongue-tied. So up here now we're going to do the third one. So we have -x plus 3y minus 4z equals 15. Once again, we're going to plug these in. So it's going to give me a -1 plus 3 times 2 minus 4 times a -2. Like before, all of this should equal 15. -1 is a 1 plus 6 plus 8 equals 15. 6 plus 1 equals 15. So all three of these are true statements, correct? So -1 to -2 is a solution. Okay, that's how you figure out if it's a solution or not. Now, if it had been, one of these had not been a true statement, then it would not be a solution. Okay. Here are the steps for solving linear systems in 3 variables by eliminating variables. First thing we're going to do is we're going to reduce the system to 2 equations and 2 variables. Okay? I do not like this highlighter. This is usually accomplished by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. Okay, second, we're going to solve the resulting system of 2 equations in 2 variables by using addition or subtraction. The result is an equation in 1 variable that gives the value of that variable. Number 3, we're going to back substitute the value of the variable found in step 2 into either the equations in 2 variables to find the value of the second variable. So we're just going to plug that value that we find back into one of the 2 from the step. Number 4, we're going to use the values of the 2 variables from step 2 and 3 to find the value of the third variable by back substituting, okay, into one of the original equations. Number 5, as always, we check the proposed solution. So those are our 5 steps. So let's do one. So step 1, we're going to reduce to 2 equations and equations, 2 variables, VAR variables, okay? So here what we want to do is we want to look at these and see which ones are going to be the easiest to eliminate. So I choose these 2, and we can eliminate the z's. Because if we multiply this by 2, then we can eliminate them pretty simply, right? So this is equation 1, equation 2, and equation 3. I usually number them just so we can keep track of them while I'm doing this. So to do step 1, what I'm going to do is I'm going to multiply equation 2 by 2, okay? So I'm just going to copy and paste this. I'm going to say equation 1 and equation 2. Now I'm going to switch colors, I would say. I'm going to multiply this by 2. So we're just going to copy and paste this one. 5x minus 2y minus 4z equals 3. Now we're going to take this 2 and multiply the whole equation by it. So this is going to be 6x plus 6y plus 4z equals -6. Okay, so this is my new system. We know that the operation is always addition, so now we can eliminate these, right? Give us 11x plus 4y equals -3. So it says we're going to reduce to 2 equations and 2 variables. Now I have 2 variables, so I'm going to call this equation 4. So now we've used these 2. So we have to use the one that we haven't used and one of the 2 that we have used. So I'm going to multiply 2 by 3 and 3 by a negative 2. That way we can, because you have to eliminate the same variable. We're going to eliminate z's again. So now I'm going to multiply equation 2 by 3, equation 3 by negative 2. All right? So I'm going to use the same color. I'm going to step over here. I need to say 2 and 3. Now, 2 I multiplied by 3, and 3 I multiplied by negative 2. Okay? So 3 times this whole equation is going to give me 9x plus 9y plus 6z equals negative 9. Now I'm going to take negative 2 and multiply it by this whole equation. So negative 2 times negative 2 is going to give me 4x minus 10y, negative 2 times 3, minus 6z, which gives me opposites is what I want, and negative 2 times 3 minus 6. To cancel, which is what we were shooting for, right? We're going to eliminate the same variable. So 9 plus 4, 13x minus y equals negative 15. Now this is our equation 5 because we have 2 equations in 2 variables. We have x and y, and here's our 2 new equations, okay? So that was our step 1. So now we have equation 4 and 5, which are 2 variables. I should say x and y. That's no good on the tape. 2 variables, x and y. Okay, so now we can do step 2. That was step 1. All of that was step 1. Okay, now we're going to do step 2, which is solve 2 equations, 2 variables. So we're going to make a new system from these 2 equations. So we have 11x plus 4y equals negative 3, and 13x minus y equals negative 15. Okay, so we have to eliminate a variable here, which 4 would be the easiest one, right? So let's multiply him by 4. I'm going to go this direction. So we're going to copy and paste the top one. X plus 4y equals negative 3. Now we're going to multiply this whole equation by 4. So we're going to have 52x minus 4y equals negative 60. Okay, so here's our new, we know it's plus. These cancel, okay? So this is going to be 63x equals negative 63. Now it's making more sense, right? So we divide both of these by 63. Our x equals negative 1. Let's box this guy. Now, we're going to do step 3, which we're going to back substitute or plug in. So we're going to back substitute into either 4 or 5. I just picked 5. No real reason. I just did. So I took 15. Shoot, 13. I don't know where 15 just came from. Sure y'all were paying attention there. 13 times the negative 1, because that's what our x equals, minus y equals negative 15. Okay? So it's going to give me negative 13 minus y equals negative 15. So let's add 13 to both sides. negative y equals negative 2. Well, we don't want a negative y, right? So y equals 2. You can multiply by a negative 1 or divide by a negative 1 either way. So y equals 2. So now we have x equals negative 1, y equals 2. So we have 2 of our 3 variables, right? Now all we need to solve for is x. So our fourth step is we're going to plug these two into one of the originals, okay? Which one you pick. I chose the first one, so I'm going to go down here. So I took 5 times negative 1 minus 2 times 2 minus, I don't have to put z in parentheses, so I'm not going to. Sorry about that. Z doesn't need a parenthesis because he's still just z equals 3. So negative 5 minus 4 minus 4z equals 3. Well, this is negative 9 minus 4z equals 3. Okay, let's add this 9 to both sides. Negative 4z is 12, right? So now if we divide by negative 4 on both sides, we're going to get z equals negative 3. The third one. Now, fifth step. Oh man, I missed my dark blue. I guess we'll do that in light orange. We're going to check. So we take negative 1, 2, and negative 3, and we plug that in to each of these. Okay, equations. So we're going to say 5 times negative 1 minus 2 times 2 minus 4 times negative 3 equals 3. And do the math. So it's negative 5 minus 4 plus 12 equals 3. Well, we know that's negative 9 plus 12 equals 3. And 3 equals 3. So we're golden there. Okay? Now the next equation is 3. So 3 times negative 1 plus 3 times 2 plus 2 times negative 3 equals a negative 3. So let's see if that works out. Negative 3 plus 6 minus 6 equals negative 3. Well, these two are just going to cancel each other out, right? It's going to be 0. So negative 3 equals negative 3. And that's good. So the last one that we have, negative 2x plus 5y minus 3z equals 3. So let's try that. I'm going to have to move it up, so y'all just work with me on that one. So negative 2 times negative 1 plus 5 times 2 plus 3 times negative 3 equals 3. 2 plus 10 minus 9 equals negative 3. I have to jump this way. So 12 minus 9. Oh, that's not a negative 3, sorry. That's a positive 3. The tape to work. There we go. Equals 3. Well, 3 equals 3, and that's true. So now we know that negative 1, 2, negative 3 is our ordered triple, and that is good. So we checked it. Okay? That's all 5 steps. A lot of work, right? For sure. Okay. Let's do another one. Now this one, there is no y on the first equation. That is not Miss Shelley messing up on her typing. That is correct in the way it's supposed to be, okay? So first step, we're going to reduce to two equations and two variables, okay? So since this one doesn't have a y, we don't have to do much with him, right? We already have that. So now we're going to look at 2 and 3, and we're going to eliminate our y. So at eliminate our y's. So since this has a 2y, we know we're going to have to multiply him by a -2. So we're going to multiply, this is 1, 2, and 3. So we're going to multiply equation 2 by -2. Sorry, I said -2 and wrote 2. Okay? So we're going to have -2x minus 2y minus 4z equals -34. So I took this guy multiplied by a -2 to get him, okay? This one we copy and paste. I don't think we're out of ink. Definitely out of ink. New color. So then here we're going to be left with -x cancel. -3z equals -18. And this is going to be our equation 4. Some are only going to need 4 because this guy helped us out, right? So now we're going to have step 2. Because we're going to solve equations in two variables. So our system here is going to be x plus z equals 8. And then now we have this one. -x minus 3z equals -18. Remember our operation here is always addition. Right off the bat we see we have a positive x and a negative x, so these guys are going to cancel. We have a positive z and a negative 3z, so that's going to give us -2z equals -10. Okay. Divide both sides by -2. Z equals 5. So that's step 1 and step 2. Now step 3, let's back sub. And we can do it into either equation 1 or equation 4. Doesn't really matter, right? I chose 1, so it's going to be x plus 5 equals 8. Pretty simple, yeah? Move your 5 over. So now our x equals 3. Okay? So we have x equals 3. It's 5. We have 2 of the 3 variables, so now we're just left to solve for, you got it, y. So we're going to take both of these. So for step 4, back sub, x equals 3, and z equals 5, to equation Well, you'd have to either do 2 or 3 here, right? Whichever one you prefer. I did this one. I did number 3. So I did 3 plus 2y plus 5 equals 16. So I chose number 3. I'm just going to circle 3 so you know which one I'm doing. Okay? So this is 2y plus 8 equals 16. Subtract 8 from both sides. That's going to leave us 2y equals 8. Divide both sides by 2. So y equals 4. There's our third variable. Lastly, we're going to check this, okay? So 5 is check. So we're going to take 3, 4, and 5 and plug those into our equations. So we have 3 plus 5 equals 8. Well, 8 equals 8 all day long, so we're good there. Now let's step to our second one. We have 3 plus 4 plus 2 times 5 equals 17. So that's 7 plus 10 equals 17. I believe we could all see that that's true. And then the last one. Okay, we're going to have 3 plus 2 times 4 plus 5 equals 16. 3 plus 8 plus 5 equals 16. Well, 8 plus 8 is 16, right? So 16 equals 16, and that one's true. So our ordered triple, is 3, 4, 5 for this one, and it's good. Kind of a long video, but the more problems we do, the better it is. So I'm not going to steps on this one. I think you guys could either look back or you should know one by now. So this one, no x, right? So he's automatically one of our 2 without a variable. So we have to look at these, and we're going to eliminate the same variable, which we're going to eliminate the x. So we're going to multiply this guy by -2, okay? So if I multiply him by -2, that's going to give me a -2x minus 4y minus 2z equals a -34. Copy and paste 2x. Why do I keep grabbing that same color? Because that's the color I did this step in earlier. Sorry, guys. -3y plus 2z equals -1. I'm a creature of habit. So what cancels here? Yes, this is a plus. We add these up, we're going to get -7y. This is going to go away, right? It's going to -2 plus 2, 0. And this is going to equal -35. So now this is one that you always want on the exam, right? Because now we don't have any x's or any z's, so we already have solved for y. So that's so awesome. Now we just divide by -7 on both sides. So y equals +5. Sorry, my bad. Getting all excited over here. So we can take this y and plug it in to this. So now we could plug y equals 5. This is equation 1, equation 2, and equation 3, and plug it into equation 1. So if we have 2 times 5 minus z equals 7. This is going to give us 10 minus z equals 7. Subtract 10 from both sides. So -z equals -3. We know we don't want a -z, so our z is going to equal 3. Here you could divide by -1 or add, or multiply, sorry, by -1, and that's going to give you z equals 3. Okay? So now we have both variables, two of the variables, and we just need to solve for x. So we could plug these two into either one of these. I chose number 2, so we're going to plug these. Equation 2 or 3. I chose 2. So we're going to say x plus 2 times 5 plus 3 equals 17. X plus 10 plus 3 equals 17. X plus 13 equals 17. Take your 13 over. X equals 4. That way we have them all written in one place, easy to see, so that we could check it pretty simply. So now let's check. So 2 times 5 minus 3 equals 7. Well, 10 minus 3, yes. So if we say 4 plus 2 times 5 plus 3 equals 17. Well, plus 10 plus 3 equals 17. 17 equals 17. Check. Okay. Last one. 2 times x is 4, minus 3, y is 5, plus 2 times 3, that's a parenthesis, sorry, equals -1. 2 times 4, 8, minus 15, plus 6 equals -1. Well, 15 minus 14, 1, -1. So we're good. So our ordered pair here would be, our ordered triplet would be what? 4, 5, 3. Because your x is always your first place. Okay. Last one. Scoot up some. So the first thing that we're going to do is we're going to eliminate a variable. Out of all of these, I eliminated the x because, like, you can multiply this by 3 and this by -2, and that's going to be the smallest, like, numbers to deal with. So that's what I chose. So I eliminated x's. Okay. So this is 1, 2, 3. Divide him by 3 and him by -2. Okay. So 2 multiplied by this whole thing is going to give me 6x. Yes, 9y plus 21z equals 39. Now -2, -6x, y plus 10z equals 44. Remember, always pluses are operation. These guys cancel. This gives me 5y plus 31z is 83. So this is my equation. Ooh, that's a Q4. Now, I've used these two, so now I have to use this one and one of these two. So I'm going to pick the one. I picked these two. So then I multiplied, I'm going to do it over here. I multiplied guy by 5 and this guy by 3 because I wanted these to be 15s. And one of them was a negative. Which one do I do by negative? This guy by -3. So they would eliminate. So this is going to be 15x plus 10y. 5 times 5, 25. Z equals. And then negative 3 gave me negative 15x minus 21y plus 9z equals 84. Now these, cancel. I have a negative 11y minus 16z equals a negative 26. And this is my equation 5. So here are my two equations in two variables. So we want to set those up as a new system. It's my new system of two variables. So I have 5y plus 31z equals 83. And then this one is a negative 11y minus 16z equals negative 26. And this is my new system. So I'm gonna, these would be the smaller numbers to eliminate. So I'm gonna multiply this one by 11 and this one by 5, okay? So then that's gonna give me, I'm just gonna move right down here. Times 5, 55y plus 341z, 913. It's gonna be negative 55y minus 80z equals negative 130. Now here's my new system. Always addition. Different color. These cancel. Going to give me 261z equals 783. Divide both sides by 261. That leaves me z equals 3. Okay? Now I'm going to plug this to 4 or 5. And I put equation 4, so I'm going to circle the 4 and just do it over. I'm going to go over here. So I had 5y plus 31 times 3. 3. 31 times 3 is 93. So I have 5y plus 93 equals 81. Subtract him over. 5y equals 10. That was a negative 10, sorry. Divide both sides by 5, and y equals a negative 2. So now we have y equals negative 2, and x equals 3. So we could plug both of these into different color. So we're going to plug these. One of the originals. Okay? So it doesn't matter which one we picked. I picked number 1, so I'm just going to circle number 1. So I said 2x plus 3 times negative 2 plus 7 times 3 equals 13. So 2x minus 6 plus 21 equals 13. 2x plus 15 equals 13. Let's subtract 15 over. 2. When we divide divide both sides by 2, x equals a negative 1. So there's our third one. So our ordered triple on this is going to be negative 1, then y is next, negative 2, and then 3. And then you would need to check it, but I'm clearly out of room, so I'm going to let you guys check it, okay, on another piece of paper. Okay, right on. Sorry the video was so long.